green book or 4.1 to 4.3 in the blue book. The do now is going to help you for the test. It kind of mimics two of the problems. And for the first one, I want you to first of all find the interval for Rolle's theorem. Now, Rolle says between two zeros that the derivative is going to equal 0. So to get the interval, you're going to find the zeros of this function. So to find the roots or find the zeros, you're going to set y equal to 0 and solve for x. Okay. So we're going to find the roots. And how do you solve that equation? What would you do first? Yeah. Well, then why take away this? Oh, you're rewriting it as to the half. Okay. You could write it to the half. What would you do, Ryan? You just square both sides, right? So we have 0 equals 4 minus x squared. And what are the solutions to that? What are our zeros? Yeah. Plus or minus 2, right? Because x squared equals 4, so x equals plus or minus 2. So the interval for Rolle's, because Rolle's guarantees between two roots, the derivative is going to be 0. So for the first part of this question, for the interval, it's going to be from negative 2 to 2. You find the zeros, and the interval will be from the smaller 0, so negative 2 to 2. Whenever you write an interval, make sure the number you write on the left is less than the number you write on the right. So you wouldn't want to write from 2 to negative 2. It's going to be negative 2 to 2. Now we want to find out where between x is negative 2 and x equals 2, the derivative is 0. So the next thing we want to do, we want to get the derivative and set it equal to 0. So we have to take the derivative of that function. Okay, so our function f of x, and this time I will, Jillian, write that as 4 minus x squared to the half. That's fine. Now we can go ahead and get the derivative. And we want to get the derivative. All right. Good. Nice. Now with Rolle's, you're trying to find out where the derivative is 0. So if I want to find out where this is 0, we're going to have to rewrite this. Now, so we set the derivative equal to 0 for Rolle's, and we want to solve, but it's hard to look at like this. So how can we rewrite this? Negative x. Okay. Yes, Jenna. So you have 4 minus x squared. You said radical? Okay. Okay, so the numerator is just going to be negative x because the half and the 2 cancel. Okay, so here's the derivative. And we want to know when the derivative equals 0 for Rolle's. We're not looking for critical points. With Rolle's, you're just looking where is the derivative 0. So if you want to find out where a fraction 0, what do you got to set the numerator equal to 0? So fraction equals 0 when the numerator equals 0, so x equals 0. Now you got to ask yourself, is 0 between the endpoints of our interval, negative 2 and 2? Yeah, right? So what do we call that value? What do they ask us to find? Did I say C, right? Yeah, the value of C. So C equals 0. Now, I just want to make sure you kind of got a picture of what we just did What we just found, first we found the zeros of this function. If you look at the function, I'm just going to rewrite it. It was y, f of x, or y equals the square root of 4 minus x squared. Does anyone know what that graph would look like without putting it in a calculator? Okay, she thinks maybe like the square root of x. Do me a favor, in your head, without writing anything down, square both sides of that equation and move things around. How many of you recognize what that is? Square both sides. Yeah, it is, right? Because if you square both sides, right, and you added the x squared, you know that's the equation of a circle, right? But we only have the positive square root. So this graph was just the graph of a semicircle. It's where the y's are positive. So the first thing we did when we found the interval for rolls, we found the zeros. So we found that for rolls says that between any two zeros, the derivative is going to equal 0. Somewhere between -2 and 2, the slope of the tangent has to equal 0. And then when we set the derivative equal to 0 and solve, we got that that occurs at 0. So we got c equals 0. Yeah. You're always finding with rolls where the derivative equals 0, but it has to be between two zeros or two endpoints with the same one. Okay, for the second do now, yeah, it's 2, because I really wanted to enforce these. This is the mean value theorem. Now we want to find the value c guaranteed by the mean value theorem, and we're given the interval. So with mean value theorem, we're not going to just set the derivative equal to 0, because the slope of the secant's not going to be 0. How are we going to get the slope of the secant? Slope formula, right? Mean value theorem guarantees that as long as your function is continuous and differentiable, the slope of the secant, that's the straight line here, it's got to equal the slope of the tangent for some value c between a and b. So with mean value theorem, the first thing you want to do is get the slope of the secant. So how are we going to get that? Well, we're going to take the change of y's over the change of x's. Of 1 minus f of 0, 1 minus 0. Let's try to do this without a calculator. So much more fun. If we plug 1 in for x, we have 1 squared plus 2 times 1 minus 1. What's f of 1? 2. Good. Minus f of 0, -1, over 1 minus 0. So what do we get for the slope of the secant? 3. Okay, so now we know the slope of the secant's 3. What's the next thing we got to find for mean value theorem? Let's say it again. Derivative, right? Because we're trying to find out where the slope of the tangent is equal to the slope of the secant. We got the slope of the secant. Now we got to get the derivative. So what would the derivative be? You don't have to number your steps. I'm just doing that. Derivative, 2x plus 2. And then we set them equal to each other because you're trying to find out where the slope of the tangent, 2x plus 2, is equal to the slope of the secant, 3. So to solve that, we set 2x plus 2 equals to 3. Now it's like our step 3, right? Now let's solve it. If we solve that, subtract 2, divide, what do you get? Right. So you get x equals a half. Now you have to ask yourself, is 1/2 between the endpoints? Is it between 0 and 1? Yeah. So what do we call that answer? C. Fred. No, C. Because they say find the value C guaranteed by the mean value theorem. You find C. Then there would have to be some other value that was. Maybe you have 3 solutions. Okay, but you would only take the values of... Yes, exactly. Correct. Yeah, that mean value theorem guarantees as long as that function is continuous and differentiable, there will be a solution, at least one solution. Somewhere the slope of the tangent equals the slope of the secant. It's a good little guarantee. We'll check. Yeah. All right. Now, on the review sheet, you know, the first one might instill fear because you just experienced having to come up with these complete graphs for that take-home quiz. But this is nothing, nowhere as hard because it's during the period, right? And the first thing that you're going to want to do, it will be a polynomial. Don't worry about asymptotes or anything like that. You're going to get a polynomial. I would pop it into the calculator, believe it or not, and I would get a graph. Now, the graph, as far as the window goes, you're going to be given the window right underneath, just like on the review sheet. Just understand that this is your x min is -1, your x max is 1.5. That's your y min, -0.5, and your y max is 1. So you go to your y equals screen, you put in the function, 6x to the fourth minus 5x cubed, you set the window, and you graph what you see. Okay? Now, that's only going to give you like 2 points, so don't get too excited as far as the graph goes. But the reason I'm saying do it first is because, you know, as long as you did that right, when you get all this other information, you're going to be able to look at that graph and see if you made a mistake. Maybe you got one of these signs wrong, and hopefully you'll catch it when you look at what the graph looks like, right? Yes, the y coordinates? Nope. Yeah, on this test, you're just going to give the x values, okay, and the interval. I'm not taking off, but what happens, like as far as the quiz goes, if you didn't rate what it was, and then you go to plot, you plotted the point, and the y coordinate wasn't right, you're going to lose the point on the graph. All right, so one way or another, you needed to know the y coordinate so you could graph it. On the test, no y coordinates. Right. You'll have the window, so you'll get a nice little graph. So this is what I'm going to be looking for. I'm going to look to make sure you got your first derivative, and you make a sign chart. Now, once you make your sign chart for your first derivative, you want to go fill out the information over there that you can. What does the first derivative tell you about the function? Increasing, decreasing, max or min. That's the information you should fill in from the first derivative sign chart. Does that make sense? Then go on and get your second derivative and make a sign chart. And that you fill in concave up, concave down, point of inflection. And just the x coordinates, that's it. So that's the way you went through. That should be easy breezy. No, I know some people kind of suffered. Yeah, it's not like there are no asymptotes, and we don't even have intercepts or any of that old stuff. Good. It's all good. Questions on this one, though? Anything? You get that? Good. We start out strong. Now, question 2, that's the one where the wording of the question was cut off. This goes back to like the first day of this unit when you're asked to find the absolute max and the absolute min of a function over a closed interval. All you need to do for these questions is find out the y coordinate at the endpoints and any critical values between the endpoints. You don't have to make a sign chart. All you need to do is figure out the y coordinate at the endpoints and the critical values. So what I would expect to see is you get the critical values, because that's where your maximums, that's where they can occur, endpoints or critical values. So you get your derivative and get the critical values, right? Not bad. In this case, since the interval for 2a was just 0 to 3, the only critical value between 0 and 3 was +1. So that's the only one I put here. And you plug each of those x values into the function. You just choose what's the greatest of these. Yeah, the highest, 25 is the absolute max, and it occurs at x equals 3. What's the absolute min? It's only one of these 3 numbers, right? Absolute min is 5, and it occurs at x equals 1. That's what you have to do for 2. So when you're finding the absolute extrema over a closed interval, you just got to find the y coordinates at the endpoints and at the critical values. think I see some confused faces, so ask me if you're not sure about that. All right? That, you're right? Yeah? Now we go on to 2. It's the same thing, only this time the function is rational. But the idea is the same. You're going to need to know the y coordinates at the endpoints and at the critical values. So you have to get the derivative, quotient rule, clean it up. When you clean up the first derivative, you get x squared minus 4x over x minus 2 squared. So critical values occur when either the numerator is 0, so sorry, that would be at 0 and 4, or when the denominator is 0. That's a 2. There are 3 critical values, 0, 4, and 2. But you only care about the critical values between the endpoints. So this interval was -2 to 1. So the only critical value between -2 and 1 is 0. So you only have to figure out the y coordinate at -2, 1, and 0. Because you're just looking for the max and the min value over that interval. So you compare these. The absolute max is 0, which occurs at x equals 0. And the absolute min is -1, which occurs at both x equals -2 and at x equals 1. Questions on that one? Okay. Let's just illustrate an MV. Okay, so for 3, this is kind of like one of the second do now. They said find the value c guaranteed by the mean value theorem for the function 5x squared minus x plus 2 on the interval from a to b. So for the mean value theorem, first thing you want to do is get the slope of the secant. You want to take f of 3 minus f of 0 over 3 minus 0. And then you want to find the derivative and set them equal to each other. So, you want to, I would get this value first. So that the slope of the secant in this one turned out to be 42 over 3, which is just 14. So you want to set the derivative equal to 14, because 14 is the slope of the secant, and solve for x. So you'd add 1, 10x equals 15, x equals 1.5, and you just want to make sure that 1.5 is within the interval. It's greater than 0 and less than 3. Sure is. So c equals 1.5. Right? Mean value theorem. Super easy. Just remember, you're going to have to get the slope of the secant first. Slope formula. Questions on that one? Nope, we love it. That was the same one. I just did it a little nicer. 4, this is like our first do now. It says, find the interval guaranteed by rolls. All right, and then find the value c. Well, actually, I forgot the wording of it. So first you have to find the interval by finding the roots. You got to get the roots, the zeros, because Rolle's guarantees between 2 roots or zeros, the derivative is going to be 0. So first find the zeros, set y equal to 0, and solve for x. And when you do that, you get x equals 7 and x equals -1. You're finding the zeros of the function. But when you write your interval, please make sure that whatever number you put on the left is less than the one you put on the right. Like, don't write 7 to -1. I'm taking off. All right? Yeah, so the interval we can use for Rolle's would be the interval from -1 to 7. So Rolle's guarantees somewhere between -1 and 7, the derivative is going to be 0. So we got the interval, that's the first part. Now we just got to get the derivative and set it equal to 0. And we get, if you get the derivative of this, it's just 2x minus 6. You set it equal to 0, you get 3. And I should have put here, you don't have to show me that you're checking, but it's always got to be between the endpoints, which it is. So the answer is c equals 3. that's where the slope at 3, the slope of the tangent would be 0. That's just the value. Just rolls there guaranteed. Use that name vector sign. Questions on that one? Well, then the fun begins. So for the rest of it, you're going to be given a graph, either of f prime or f double prime, and you're asked about one of the other two. So if I give you a graph of the first derivative, I'll ask you questions about the function or the second derivative. What if I give you a graph of the second derivative? What would I ask you about? The function or the first derivative? Okay? So we know with these questions, it's very important, first of all, oh, it's nice, that you know that chart, right? As we were doing yesterday. So that's something you'd really want to make sure that you can. Oh, nice. So yeah, during the test tomorrow, you can just take your phone out. You can just look at it. Oh, wait a minute. Don't do that, kids. All right, so the big thing is whatever you're asked for, you know, if you would get this chart, you just go over to the column whose graph you're given. So these are kind of fun. Number 5 was a little awkward, only because you had to find the answers. With 5, you're given a graph of the actual function. Oh, I have to have an actual thing here. So for 5, you're given the function, and the first thing it says, estimate where the first derivative is 0. You never look at the graph right away, right? You got to think, what does that mean about the function? The first derivative, that's just, what does the first derivative mean graphically? Slope of the tangent. So that's like saying, where is the slope of the tangent 0? Or where does f have a horizontal tangent? Then you look at the graph. Good? So if you look at the graph, it's going at 1 and 3. Yeah. Just look at it and know. But if I were you, what I would do on the test for these kind of questions, make that note to me first, like what you're looking for. Like for B, yeah, like what's going on with F, like in this case. Like B, it says estimate where the first derivative is positive. Well, what does that mean about F? Yeah, I'd like to see, like if you guys wrote F increasing, then if you go and you do something stupid, I can at least give you, well, something great, different. Then if, but if I see they understood that the first derivative is positive means the function is increasing, I can give you partial credit for that. Okay? Then answer, you know, of course, answer the question. But yeah, I would put the justification here, what you're looking for. Then you could say, okay, it's increasing. Now, the one that you had on the review, you had to find the answers. You're not going to have that in tomorrow's test. But like on the answers, you had to find, they didn't say negative infinity to 1. They had one of the choices was x was less than 1. And they didn't write an interval notation 3 to infinity. You had to find x is greater than 3. So this one had 2 answers. It's a big. That's why on the answer key I have. And then C, estimate where the first derivative is negative. What am I looking for with F? Decreasing. So then you look at the graph and you look to see where is it decreasing. So from 1 to 3, you give your answer, right? But yeah, this justification part is going to help you out. Yeah, it's just a good thing to do because I can't tell you how many people will tell me when they see like C, estimate where the first derivative is negative, they're going to tell me where this one's negative. Even though I've warned you, I'm never going to ask you about the graph that you're given. All right. And then the one, I think D, estimate where the second derivative is 0. What are you looking for? Point of inflection. Now, you had to kind of guess where it was. You knew you had a max at 1 and a min at 3, and the point of inflection was somewhere in between. Yeah, so we were going with 2 because that was the only one choice there that made sense. So that was x equals 2. And then at E, I'm sorry, question E, estimate where the second derivative is positive. What are we looking for? That function's concave up. and that starts at the point of inflection and goes off to infinity. So from 2 to infinity, or x is greater than 2. And then finally estimate where the second derivative is negative. We're looking where the function is concave down. So x is less than 2, or from negative infinity to 2. So that was a graph of the function. And then there was a graph of, whoops, that's the function again, of the first derivative. Now, the only thing with this one, I didn't give you all the information that you needed. I gave you the equation of the first derivative, so you could pop it in your calculator, because on the review sheet, I only gave you the zeros. I told you it's 0 at 0, -1, and 4. And I do this little sketch here. But that was not enough information to answer the questions. Because even though it was fine for the first question, what intervals is f increasing when the derivative is positive, knowing the zeros was good enough. For part B, where is f concave down? A function's concave down when the first derivative is decreasing, because the second derivative is negative, okay? But it's the first are decreasing. So you couldn't tell where it was decreasing until you knew where the max was and that min was. Like you knew it was decreasing from negative infinity to -1, but you weren't given the x-coordinate of that max. So that's where that came from, that -0.351. I had to go to the calculator and actually graph it and get that max. I don't think I'm going to do that to you tomorrow, but you should be able to get a max and a min of a function given its equation. But yeah, you needed those. And then you could just say where it was decreasing. Points of inflection. If a graph is a point of inflection, second derivative is changing, but what does it mean about the first derivative? Max or min? You know, look for those. You know the chart, you'll be good, right? And then the last one there, does the function of relative extrema. The function is relative extrema when the first derivative changes sign. So then you look to see where it actually crosses. Okay, so these are the connections you want to make. You always want to relate it back to the graph that you're given and then answer the question. And then there were 4 questions on the second derivative. You're ready for this. Well, a lot of this is like repetitive. I don't have a graph hip here of the second derivative for the kids at home. Well, I guess I should. I'll try to fill it in after. Well, I guess I should. Well, the first part says, where is the function concave down? What does that mean about the second derivative? It's negative, right? So if you look, if you had this thing in front of you, oh, it's going to be too small. I'll never do it. Okay, something like this. It's interesting. Thank you. Let's see. This is A, and this one is B. All right, that's a little B there. That's pretty bad. Sorry about that. But the big thing to realize, what am I looking at? That's the second derivative. So you had to find where it was negative first. It's all right if you just go all the way from A to E, or you could break it up at C. Did I pull it out? Almost. That was dangerous. Down goes up. Functions concave down when the second, oh wait, oh, I'm reading the wrong question. Okay, B, where does f have a point of inflection? That's when the second derivative changes sign, right? So then you look to see where it changes sign, where it actually crosses the x-axis. Where's the first derivative increasing? That's when the second derivative is positive. So you look where this one is positive. And the last one, does the first derivative have any relative extrema? That's when the second derivative changes sign, and then you could identify them. Any questions that you get the gist? All right, I know some people want to hand in the quiz, so we'll say see ya. Oh, God.